Section 3.4, we're going to find and use slopes of lines. So this should be pretty familiar to you from intermediate algebra. You're going to find the slopes of lines and slopes of lines that are parallel and perpendicular to a given line. So just a quick reminder about slope. The slope of a non-vertical line is the ratio of any vertical change rise compared to any run between any 2 points, horizontal change. So slope is rise over run, or y2 minus y1 over x2 minus x1. So another thing to keep in mind when you're comparing the slopes to see which line might be steeper than another, we always compare the slopes of lines, and the steeper line has the slope with the greater absolute value. So we don't worry about if it's positive or negative. We take the absolute value of it to see which number is bigger. So that's just a quick review about slope. So we also talk about positive, negative, zero, and undefined slopes. So a negative slope is kind of what you expect as you look at your graph left to right. It falls. So line J has a negative slope. And on the other hand, line K has a positive slope because as you look at your graph left to right, it's going up. Zero slope is when basically you don't have any rise. It is a horizontal line that has a zero slope. And last but not least, undefined are verticals. Okay? Now, how I like to remember it between horizontal and vertical lines, zero and undefined, is if you are going to ski or bike down this hill, that slope is way too steep to define. Versus if you are on this line right here and you're trying to go down, you get zero slope because you're not going anywhere. It's not. So if we look at these value or these lines right here, can you determine which is which? So give that a try. Line A is our zero, and line B is our undefined slope. And then line D is positive slope, and line C is negative. So hopefully that's pretty basic and you can fly through those. But we can actually put a value on the slope as well. So again, rise over run. If you have 2 points listed, you actually can just use those ordered pairs as points on your graph. So like here's -3, -3, and here is 6, 4 right here. And so you actually can count your slope, rise over run, but sometimes if you have decimal points and things like that in your ordered pairs, that's going to be difficult. So we'll just use y2 minus y1 over x2 minus x1. And I think it's helpful to label your points, but you guys can probably handle not doing this. But just pick your y2 value, which is -3, subtract your y1 value, which is 4, over x2, which is -3, minus your x1 value, which is 6. So you get your slope then is -7 over -9, which a negative divided by a negative makes positive. So your slope is 7 over 9. And we usually leave slope as a fraction. If you label your ordered pairs the opposite, you would still get the same slope. So it doesn't matter how you label them. So now it says find the slope of the line that passes through the following points. So I'm not going to do all of these because I think this is something that you're probably pretty good at. But let's go through at least one or two of these, and then you can certainly go through the rest of the examples and check the notes. So to find the slope of this line, I'm going to take 8 minus 3 over -7 minus a -7. So that is going to give me 5 over 0. I don't leave my slope like that though. And you can't divide by 0. So when 0 is your denominator, that is what undefined would be. if 0 is your numerator, then that has a slope of 0. And if you want to just check that on your calculator, if you take 5 divided by 0, it'll give you an error message. If you take it the other way around, 0 divided by 5, it gives you 0. So we'll go through one more on here. So we get 8 minus, so y2 minus y1, so 8 minus negative 3 over x2 minus x1, 7 minus 2. So now we get 8 plus 3, which is 11 over 5. So again, there's your slope. All right, so what about parallel and perpendicular lines? Well, there are two postulates related to this, and postulate 17, in a coordinate plane, two non-vertical lines are parallel if and only if they have the same slope. And any two vertical lines will be parallel, and any two horizontal lines will also be parallel. So parallel lines have the same slope. And postulate 18 says in a coordinate plane, two non-vertical lines are perpendicular if and only if the product of their slopes is -1. And what that means is the slopes will be opposite reciprocals of each other. And so now horizontal lines will be perpendicular to vertical lines. So tell whether the lines through the given points are parallel, perpendicular, or neither. Well, we need to find the slope of each line. So I'll start by finding the slope, m. We use that letter m for slope. So I'll find the slope of line 1. So I'll take y2 minus y1 over x2 minus x1, and that gives me a slope of 4 over 1. So now let's find the slope of line 2. So when I do that, again, I'm going to take y2, which is -2, minus my y1, which is -3, over x2 minus x1. Again, subtracting negatives, be careful with all of that, but this is going to give you 1 over 6. So what happens is my two slopes are 4 over 1 and 1 over 6. They're not the same, and they're not opposite reciprocals. So these lines are neither. They are neither parallel or perpendicular. So now let's look at one more example and see what this looks like. So now I'll do the slope of line 1 again. So now I get y2 minus y1 over x2 minus x1, which gives me 7 over 14, or 1/2. So now let's find the slope of line 2. And if they're the same, they will be parallel. If they're opposite reciprocals, they will be perpendicular. So slope of line 2 is 2 minus 4 over 2 minus 1, which gives me -2 over 1. So now if you compare these slopes, 1/2 and 2 over 1, they are opposite reciprocals. These slopes right here are opposite, meaning one is positive, one's negative, and the fractions are flipped, so that's reciprocal. So they're perpendicular. And remember, we said if they're perpendicular, the product of their slopes will be -1. And if you take 1/2 times -2 over 1, you get -2 over 2, which is -1. And that's the opposite reciprocal part. Okay, there are two more postulates that I think are important to note. They actually come from 3.1, but they fit here because we're talking about parallel and perpendicular lines and so forth again. So the parallel postulate says if there is a line and a point not on the line, so here is your line and here is your point not on the line, then there's exactly one line through that point that will be parallel to the given line. So there's exactly one line that will be parallel that goes through that point. And the perpendicular postulate says if there is a line and a point not on the line. So again, we're starting with the same scenario. So if there is a line and a point not on the line, then there's exactly one line through the point that's perpendicular to the given line. So that this is the only line that would be perpendicular that goes through that point and perpendicular to the given line. So those things are pretty important, and they come up at times when we're proving different things and just when we're trying to solve problems. So now we're going to do some graphing. It says graph the line through the given point with the given slope. So to do that, the first thing I do is plot the point. So -4, 7 is right here. That's point P. Now I use my slope to get to the next point on the line, which means I have a rise of -3 and a run of 2. So when I rise and it's negative, I go down. So 1, 2, 3, and then I go to the right 2, 1, 2. So rise is -3, run is 2. I do it a few times, and then I connect my points, and there I have graphing a line. So that's a quick review of graphing the line. So now let's use those parallel and perpendicular postulate. It says line M passes through points 1, 7, and 7, -4. What is the slope of a line that's parallel to M? Well, we could graph these points. It doesn't tell us to do that. We don't need to. What we need to do, though, is we need to find the slope of line M. So, again, y2 minus y1 would give us 7 minus a -4 over 1 minus 7. Doesn't matter if I switch the order of the ordered pairs. It equals 11 over -6. So, parallel to line M, your slope will equal the same. So, remember, parallel lines have the same slope. So this is the slope of M, and this is the slope of a line that is parallel to M. And if we were asked to find the slope of a line perpendicular to M, so the slope of the line perpendicular to line M would equal the opposite reciprocal, so it's going to be positive 11/6. And line H passes through points 3, 0, and 7, 6. Graph a line perpendicular to H that passes through 2, 5. Okay, so again, we want a perpendicular. So first we have to find the slope of line H. So I'm going to take 0 minus 6 over 3 minus 7, and that's going to give me -6 over -4, which is 3 over 2. So the perpendicular slope is going to equal the opposite reciprocal, -2/3. I want it to go through the point 2, 5. So what I'm going to do is I'm going to make a grid, coordinate plane, and I'm going to plot the point 2, 5. So 1, 2, 1, 2, 3, 4, 5. That would be right here. So that is the order, or the pair 2, 5. Our point is going to, or our line is going to go through that point, but it's not going to have the slope of 3 over 2. It's going to be -2 over 3. So that means I'm going to go down 2, 1, 2, and to the right 3, 1, 2, 3. Down 2, right 3, and there is my line. Okay, so we just did a bunch of review on slopes, graphing, parallel, and perpendicular. That's the end of lesson 3.4.